Good morning all of you. In this video we will learn to analyze and design of tall building. Today we will design a 23 multi-story building in which the lateral section of the building is different for different set of stories. The live load is also different for each set of floors. For story 1 to 8, live load is 5 kN per meter square. For story 9 to 14, live load is 4.5 kN per meter square. For story 15 to 19, live load is 4 kN per meter square. And for story 20 to 23, live load is 3.5 kN per meter square. Also, three sections of beams and column each are listed, each of which are having M40 concrete and HYSD 500 and mile 250 rebar for longitudinal bar respectively. The cross sections of three beams are 500 by 300 mm, 550 by 350 mm, 600 by 400 mm, and the cross sections of the three columns are 500 by 500 mm, 550 by 50 mm, 600 by 600 mm, and the thickness of a slab is 150 mm, and the value of cladding load is 0.2 kN per meter square, and we will use auto draw cladding option in this video. For the wind load, we will consider the parameter for a building to be constructed in a Bangalore city. So open the ETAB software, select new model from the file menu, uh, change the display unit to meter SI, steel section database to Indian, design code set as IS 800 2007, and concrete design code as IS 456 2000. Click on OK. In uniform grid spacing, number of grid lines in X direction set as 4, and number of grid line in Y direction set as also 4. Spacing in grid in both X and Y direction are 6 meter. In story dimensions, set as number of stories as 23, and typical story height and bottom story height are remain same as 3 meter. Now you need to define set of similar stories. So select the custom story data and click on added story data. You can see that 23 story is set as master story. So all the stories are similar to story 3. This this means all the stories are similar now, and we will create different master stories into smaller set of smaller stories. Story 1 to story 8 are similar. So go to story 8 and set the go to story 8, and in the master story option select yes. Then set the other stories are similar to story 8. So all are set to similar to story 8. Similarly, story 9 to story 14 are similar. Set any one story to the master story. So go to the story 14 and set as yes, and similar to story 14. Again the third set of stories 15 to 19 select 19 story as a master story, and set all the similar stories to story 19. The remaining story from 20 to 22 are already similar to story 23. So now we have created four different set of similar stories and we can assign property to only one set using the similar stories option while modeling. So click on OK to exit. Select grid only options and click on OK. So the 3D grid has been created for us to draw element on it. Firstly, we have to define material properties. So go to the define, click on material properties, click on add new properties, select region as India, material type as concrete, standard as Indian, and grid as M40. And click on OK. And click on OK again. Click on add new property. Okay. Now we have to define the section properties. Section properties of frame, slab and column. So go to the define, select section properties, go to frame sections and click on add new properties. Select concrete shape and change the property name to column 500 cross 500. Change the material type to M40 and change the section dimensions to 500 in both in depth and width. For reinforcement property, select modify slash show rebars. Keep the default set design type to column and change the rebar material. Oh sorry, we do not define the longitudinal bar materials since yet. So click on cancels. First of all we have to define the material properties. So click on add new materials, concrete rebar, material 500, click on OK. Again click on OK, add new materials, click on rebar. Now we have to change only the grade. So now we define all the three properties which we used. Okay. So again go to the section, frame sections, add new properties, click on column, rename the sections, C500 cost 500, change the material type to M40, change the dimensions 500 cross 500. For reinforcement properties, select modify slash show rebar, change the longitudinal bar to HYSD 500 and confinement bar as mile 250, and cross check the clear cover for confinement bar is 40 mm and click on OK. Click on OK again. So the column of 500 by 500 section has been defined. Now we will need to define two more columns which are having similar properties of this, with only different being the section dimensions. So instead of click on new property each time, click on just column and click on add copy to property and change property name to second column, that is C 550 cross 350. No, 550 cross 550. Change the material type to M40 and change the depth and width to 550 mm and 550 mm. If you click on the modify slash show rebar, you will see that you will see that the setting of a previously you can see that we will see that the setting of a previously defined column are already there, so we we need not define them again. So click on OK. Click on OK again. So section of 550 cross 550 dimension has been defined. Similarly, select the column 1 more time and click on add copy to property. Change the property column to C600 cross 600. Keep the material same as M40. Change the section dimensions to 600 in depth and width. And click on OK. So all three sections of cross sections of columns are been selected. So click on individual section every time. We have to click on add new properties. Click on add new property. Here under the special option we will find the option auto select list. Click on auto select list option. Select, change the property name to auto select column. Change the material type to concrete. Select all three defined column and click on add. Now the three column selection have been added to the auto select option. Click on OK. Now while drawing the column, we will not be using the individual section but the auto select list property, and software will automatically select the best section from the list depending on the internal forces. Now click on now add new property and select concrete rectangular section and define the beam cross section B 500 cross 300. Change the material type to M40 and change the section dimensions to 500 to 300. Click on modify shear or reinforced bar. Change the design type to M3 only. Change the longitudinal bar to HDISD 500 and confinement bar to mile 250. And provide the cover to the longitudinal rebar group centroid to 25 mm. Both bars to bottom and click on OK. Click on OK again. And click on select the beam cross section define and click on add copy to property. Change the property name to be 550 cross 350. Remains, don't change the material type to M40. Change the section dimensions to 550 cross 350. And here we do not need to click on the modify shear rebar, so click on OK. And again select the beam and click on add copy to property. Change the property name to be 600 cross 400 and change the dimensions 600 and width to the 400. Click on OK. So click on add new property and select auto list options. Change the property name to auto select beam. Change the material type to concrete and select all the defined beam and click on add. So all three we defined beams are selected in auto list. Click on OK. So here we defined the beam and the column for different sections. So now we have to define the slab section. Click on OK. Go to define. Section properties, slab sections. Add new property. Change the slab name to slab 150. Change the slab material to M40 and change the thickness to 150 mm and click on OK. I click on OK again. In this plan view, go to story 1 by using up and down arrow. Now select quick draw column option from the define menu. So in draw menu, quick draw options. You can also select the quick draw column from the shortcut bar. So click on this icon and change the column property to the auto select column. Select similar story options at the bottom corner. Similar stories options we have selected. Then select whole grid area to place the column at the grid intersections. As we selected similar story option, we can see that column have been drawn in all the similar stories 1 to 8. Now select quick beam options. Change the property type. Change the property type to auto select beam and select the whole area. So the beam as are drawn to select in story 1 to 8. Now we have to select the slab. We have to draw the slab. So click on the quick draw slab options. Change the slab property to the previous defined property and select the whole area to draw the slab. So we can see that the slab beams and columns are drawn from story 1 to 8. The beam, column and slab have been defined to the similar set of stories. Using the arrows, go to story 9. Cross check that the similar story option is selected or not. Click on the quick draw column option and draw the column over the desired area are displayed. Similarly, click on the as we can see that property is already select as auto select option which we select in previous steps. So click on the quick draw beam option and draw the beam over the desired area. Now we have to draw slab also. So click on the quick draw slab option. The slab story and the slab property is already predefined, and draw slab one by one. So we can see that all the slabs, beams and columns have been drawn similar set of story using the up and down arrows. Go to the story 15. Similar story option is already selected. Click on quick draw column option. Auto select property is already predefined, and select the column are drawn in desired area. And click on the quick draw beam options and draw the beam. Now draw the slabs on it. First, define the wind load. Select load pattern. Type the name as a wind and type is also wind. And auto letter load, select IS 875-1987 and click on add new load. Select the new added wind load and click on modify letter load and here for the wind load setting we have referred to IS 875 part 3. So open the IS code and scroll down. Considering the building to built in Bangalore, the corresponding wind speed comes to be 33 meter per second. Enter the wind speed value of 33 meter per second in this software. For the train category, refer to clause 5.3.2.1. The train of Bangalore falls under category 3, so select the train category as 3 in E-tabs. For the structure class, the height of a building is more than 50 meters, so select the structure class as C. And the risk coefficient, K1 factor and topic remain same as 1. And considering the mean design life of a value building as 50 years, the topography K3 factors taken as 1. Click on OK to store the setting of the wind load. Click on OK to exit the defined load pattern. Now we will be assigning the wind load on the building cladding. With the plan view tab selected, click on elevation view. Select the elevation side A and click on OK. Select all story option and select all the cladding shells. To identify the wind pressure coefficient, open the IS code again and scroll down to table 4. The height of a building is 23 times 3, which comes to 69 meter, and the width of a length of the building are both 18 meter. Thus the height of a width ratio is 69 by 18, which comes to 3.83. As the value of between 1.5 and 6, go to the particular subcategory of height by width ratio. The length and the width both are 18 meters, so length by width ratio is 1. Hence go to the subcategory of length by width ratio between 1 and 3 by 2. Check for the wind pressure coefficient under this category. The coefficients are 0.8, minus 0.25, minus 0.8 and minus 0.8 for sides A, B, C and D respectively, as per the building plan on the IS code. Now in the software, Select all the shells. All the cells are already selected. So go to assign, shell loads, wind pressure coefficient, change the coefficient value to plus 0.8 and select the windward option and click on apply. The wind load has been applied to the section A. Click on OK to exit. As visible from the 3D model, the side A of a building plan is in the IS code also correspond to some shells of the section B in the higher stories. Select the elevation option and select the section B and click on OK. The remaining cladding in the windward sides of the building which will be subjected to the wind load are visible. Select shells one by one. Using the all story option, select all the shells. Apply the same wind pressure coefficient of 0.08 in the windward direction to the shell and click on OK. Once wind load is applied, go to the plan view option and select story 1 and click on OK. Now the opposite sides of windward direction, that is this side B from the IS code, correspond to section C and D for different stories. First go to elevation view and select section D and click on OK. Select all the shell with all story option. The corresponding wind pressure coefficient for this side is minus 0.25. Go to the assign shell load wind pressure coefficient option. Enter the value minus 0.25 and direction and leeward and side click on apply. The wind load the wind load the wind load is applied in the section B. Go to the elevation view and select the option C and click on OK. The wind load in this section will also be minus 0.25. Select the visible shells and apply the wind pressure coefficient to the minus 0.25 in the similar manner. The wind load on the sides A and B as per IS code has been applied. In the elevation option, select section A and click on OK. Select all the shells using all story option. Using the up and down arrow key, navigate the elevation section 2, 3 and 4. And select all shells in each section. Once all the shells are selected, go to assign, select shell loads, click on wind pressure coefficient, change the coefficient value to the minus 0.8 and change the direction and select the leeward side direction and click on apply. Click on OK. The wind load in the elevation section 1, 2, 3 and 4 have been applied. The software will so go to the plan view and select story 1 and click on OK. The loads are applied in all the shells in each sides. Go to any story from the second set of similar story. In this way you can verify the wind load and direction in the other set of similar stories as well. All the properties, sections and loads have been applied to the building model. Now we will learn to run analysis and design on it. Select the 3D view tab and select the use extruded view object from the toolbar. The frame extruded view of the building is shown. Go to the analyze menu and select run analysis. Otherwise you can press the F5 button. Save the file if you do not save it yet. Go to analyze and select the run analysis is done. It's in processing, sorry. Once the analysis is complete, you will check the displacement values. The other analysis results like the forces and stresses can be viewed by selecting the suitable options by display menu and show. After analysis, we will run designing of the building. In the design menu, select concrete frame design. Click on start design check. Wait for some time as the software runs designing on the building. As we can see, a warning is shown on my screen. Once design is complete, we will get a notification that analysis and design section differ for a particular number of frames. So click on yes. This means that initially the software uses the smallest concrete frame from the auto select list, which is the 500 by 500 section of column and 500 by 300 for beam. In this case, this time after the completion there is no notification regarding the failure. This time after the completion of running design, there is no notification regarding failure of any members. The, the 3D view shows the 3D view. This time after the completion of running design, the 3D view displays the longitudinal reinforcement. You can check by the going design, concrete frame design and select verify all the members first. One concrete member is failed, so design check, do you want to select them?
अम्मी उठ जाओ सुबह उठनी मत करो जब तुम्हें पूरे दिन सोनी हो जाए तो
Thus the design of a building is completed. You can zoom in the 3D view tab and check reinforcement value in each member. That's all for my today videos. Thank you.